Okay, thanks again, everyone, for joining. I'd like to introduce Tony Sherman. He's a software engineer at BusPatrol, where he works on backend architecture using Python. And this evening, he's be giving a talk on serverless programming in Python. He also lives in Michigan with us and over in Zeeland. And thank you so much, Tony, for joining us and giving a talk. Tony was also on Talk Python to me. That's where I initially heard him, so he's a little bit Python famous. So And so, yeah, thanks, Tony, for joining and take it away.
Yeah. Yeah, thanks. Thanks so much. It's funny that you mentioned that because you're talking about new speakers. I haven't given conference talks or anything. I just yeah, and ended up on Talk Python, which is I'm a longtime fan of Talk Python, so it was kind of I was a little starstruck to even be on there. But yeah, let's get into the talk. So you gave me a little bit of an introduction already, but yeah, I'm a software engineer at BusPatrol and uh, mostly doing, yeah, as you said, our backend architecture in Python. We have a couple Ruby on Rails applications that have kind of been running the core of the business, and we're working on migrating those into a lot of different microservices, which involves a lot of serverless programming. Um, yeah, so about Bus Patrol, what just to give you a little, you probably have not heard of Bus Patrol if you're like me before I joined a little on over or a little under 2 years ago. We're a school bus safety company, so we equip school buses with video cameras, and a lot of the business model is actually capturing when stop arm violations happen. So if a car drives by a school bus, we capture that footage, determine if it was actually legally a violation, and everything from it we automate as much of that process as we can, and then have a human reviewer kind of compile the smallest amount of evidence to give to a law enforcement officer who can say, yes, this was a valid ticket. And then um, uh, we actually do issue and print the citation and everything. So a lot going on behind the scenes there. But yeah, uh, I enjoy Python, definitely a language I enjoy working in, enjoy open source. I'll share some of my favorite open source projects that I use for serverless programming. And serverless isn't tied or isn't limited to AWS, but that is my world lately. So a lot of my examples will be AWS specific, but a lot of the big cloud providers have very similar, if not the same, offerings. Um, so I'd like to cover just brief overview of serverless, some best practices. Uh, there's so much to go over with best practices, and we could probably get into some fights. So I'll just touch on a few things. Packaging is probably not limited to serverless. That's probably just a Python problem in general, and I do have a very cool tool to share for that. And then uh, a demo and some performance items we can go over. So um, yeah, so serverless does run on servers. The it's that can't be hidden anymore, I guess. So the big benefits you get though is that you don't have to, for the most part, manage these servers. You're not spinning up VMs. You're not seeing, choosing how many CPU cores you need, or uh, how much physical storage. It's just compute or other services that you don't have to think about. So there's serverless databases and data stores. The DynamoDB is a big serverless database that AWS has, which is just a managed NoSQL database. And then there's serverless compute. So functions as a service, AWS Lambda. There are some container options too. There's Elastic Container Service, I think, is the serverless, Docker containers, and Google has Google Cloud Run, which I might even like better than AWS's offering, to be honest. But there's a lot of serverless options out there. And some of the benefits that I already stated, you don't have to manage the servers, but the scale is a really nice thing. So as you can imagine with like school buses, we have a huge spike of traffic in the morning and then a huge spike of traffic in the afternoon. And so we can go up to, millions of requests a couple times a day. And then, there's no servers running in between those times or at night or on the weekends. Uh, it can kind of fit what you need. Um, and yeah, it might not be the answer for everything, but I definitely would encourage you to at least explore it, kind of see what you can do out there, especially if you have a lot of personal projects. You can do everything in a static website, but you just need, that one little bit of functionality. You could probably do it in just a Lambda function. So um oh, and I see there's some questions. So just, I mean, feel free to interrupt me. I'm very um yeah, very open to discuss some of this. I love talking about it. So yeah, it says Google offers serverless, yeah, Cloud Run. Yeah, there's a lot of different options for serverless. I like Google Cloud Run for their containers because that truly scales to zero. I don't think ECS actually does, but we'll spend probably most of this talking about serverless functions. And yeah, AWS has them, Google, Cloudflare. Uh, I don't know what Microsoft's or Azure, what theirs are called. Vercel has them. Um, but you really just have to bring your function code, and don't have to think about much else than that. So um, how it kind of, with functions as a service, AWS, they use, something called like a micro VM. And so it basically is a VM. It can spin up very quickly, execute your code, and then, shut down to an extent, very simplified version of that. Um, but yeah, you can do a lot, and you can do a lot, with a pretty quick time to market. You don't have to think nearly as much about infrastructure. There obviously is some, and you kind of get into potentially some specialization, if you especially I mentioned that I get into a lot of AWS specific things because that's the cloud provider that I'm most familiar with. Um, so best practices, I'm really just going to touch on a few here because there's an open source project that I think kind of really helps you enforce these. So uh, serverless, you do kind of have a different mindset where you can't SSH into a server and tail some logs. There's you have some limitations. It's only running, AWS Lambda has a 15-minute runtime maximum on a Lambda function. So you only have a limited amount of time that you even have this environment available, and you know there's things that you can't even access because it just runs and shuts down. And unless you have a way to kind of get something out of the environment, you don't have any insight there. So um, observability is a definitely something you have to keep in mind. How are you going to log? Like I said, you can't just like tail these logs, so you have to aggregate them somewhere. So there, you might need to dump all of your logs into, Splunk or Datadog or CloudWatch or whatever log aggregation you want to use. Um, and so it forces you to write a little bit differently. Single purpose functions, I said mostly because the example that I'll actually show isn't truly single purpose. But for the most part, you don't want a Lambda function that's doing a ton of different things, because if one part of the process fails, then you might lose something else that you want. So you don't want to be like, okay, on this function, I'm going to write to a database and then log it, and then send an event to a message queue, and then do steps A, B, C, and D all in a single Lambda function. There are certainly times where you can do multiple things or have a Lambda function that's used for multiple tasks too. So it's not a hard and fast rule. There's an excellent talk that I have a link to. I'll have to figure out how to share these slides with everyone. But AJ, I believe it, I don't know how to say his last name, Stuyvenberg or Stuyvenberg, I'm not sure, but he did a reInvent talk on cold starts. And so I gotta realize I have to back up a little bit. These runtimes, they fire up, and then so the big, part of that firing up is bringing your code into that environment. And so what AWS does is they actually keep that runtime available for future invocations for a period of time. So you'll hear something called a cold start with Lambda, and then a warm invocation, I suppose, after. And so all that code that you have to bring into the runtime takes time, and you want to limit that as much as you can for performance reasons. So you do need to organize your code, and as your code base grows, you want to architect that in a way that you can know what you're shipping, um, and being able to keep those as small as possible, especially when it comes to you have to think, you're not just so quick to maybe pull in that third party library just because it's really convenient, because some of those are very large libraries. So the tool that I found the best for this is it's an open source library called AWS Power Tools for Lambda. They actually have it available in several languages. I think they have it in TypeScript, .NET, Java, I think is also offered. They might only have 4 right now. But a lot of these best practices, they kind of enforce with code. So there's a lot of different utilities there. So I mentioned observability briefly, and they have a structured logger. They have a tracing utility. If you want to use like AWS X-Ray, they have ways to create metrics in your Lambda code if you have something you need to track. Um, and how Lambda functions work is you just have a single handler function, and it accepts 2 arguments, event and context. And the event is always some kind of dictionary that's essentially a big JSON blob of data. And depending on how you're invoking it, especially throughout AWS, you might be doing this as an event from when something gets dropped into an S3 bucket, or you might have a HTTP endpoint in front of it. So you might use something like API gateway or a load balancer. And so all of these events look just slightly different. And you probably only need something like for a REST API, you might want to know the path that it came in on. And, if it was a post request, you might want, the body of that post. And so they have data classes for these, and they'll validate that it is the event you're expecting, and you can obviously inherit those to have customized bodies, or you can bring in Pydantic. Is there anybody using Pydantic very much? If you're not familiar with Pydantic, it's just really nice library for uh, using type hints in Python to structure some objects and get some great validation utilities there. So um, they have a lot of other utilities. They have an event handler. So if you're coming from Flask or Fast API, the syntax is almost identical, where you create a router and then you add your routes for post requests, get requests, and the like I said, the syntax is very similar. So you could probably migrate a smaller, you know, uh, uh, Flask application or Fast API application to a Lambda function pretty quickly. They have an item potency utility. So a use case we had for this was we were one of our older applications was just like spamming these emails to people for these notifications, and they're like, I got 57 emails for the same event last night. What's going on? And with this utility, it will check your the history of your function execution and be like, oh, I've already returned an event for this, so I'm not going to do everything. I'm just going to give you the same result back. So in our case, we were able to just say, oh, yep, the message sent. This was a successful request, and so that item potency utility is very nice. Message queues are a big thing in AWS. There's SQS. You can do Dynamo DB streams, and so there's ways to batch process these. Where if you're processing tens or hundreds of records at a time, you can the default way for Lambda is if one of these fails, they all go back in the queue. But they added a feature where you can just say, oh, record A, B, and C failed, send those back to the queue. So Power Tools has a really nice batch processing utility for that. And you can just pick and choose whatever ones you want. So you don't have to, it's not like you have to restructure all of your entire code base, but you can start bringing in these features and uh, really get a lot of best practices just from using their library. So yeah, packaging. Uh, I, I said it's probably not just a serverless problem. It's probably a Python problem. I haven't really packaged a like a PyPI package, but I'd imagine this probably um, is a problem anybody with Python has run into. Uh, for Lambda, you can package your function code in two ways. There's just a zip file. You can take your all the code that you need and put it into a zip file and ship it to AWS. The limitation on that is, I think it's like 50 megabytes zipped or 250 megabytes uncompressed, which you can run into most likely with third-party libraries. If you start bringing in some of your data science libraries, that's probably when you would be hitting those. So then you have container images, which those I believe is like a 10 gigabyte limit. And it used to be that container images weren't as performant, especially on that cold start. But I think AWS has really done some kind of magic behind the scenes to get those pretty close to the same performance. The I tend to lean towards the zip archives because they're just you can unzip a file and know exactly what you're shipping. The container's a little bit uh, it can kind of hide what what you're shipping if you don't know exactly what you're looking for in the image itself. So as far as other serverless functions as a service, I don't know exactly how they package things. So I should do a little dive into some what are the other other ways that cloud providers do that. But so let me see. Okay, yeah, let's look at some example code here. So if we have this kind of folder structure that is just maybe you have a REST API with a couple endpoints, one, two, for your like read operations, and then another, we'll say this is another endpoint or multiple endpoints that's your create, update, delete operations. And then maybe you have some type of database model in another folder, and maybe you have a data access layer where you're retrieving the items or writing them to a database. Hopefully you have some test code as well, probably some documentation. So if you need to package all this up, in theory, you could just zip up this entire folder, right, and ship it. And as long as you're within the constraints of your provider, then then yeah, absolutely, that's fine. But if you go back to that no and reduce the code you load, you probably don't need to ship your test for your application code. So, and if this is a large repo that's thousands of files, then you don't want to be you probably can't you will be running into limitations as on the size limits. So I came across actually I think I heard about Pants Build on the Talk Python podcast. So Pants Build, they have a lot of different tools available that is really good for large code bases, specifically mono repos, which is probably a pretty popular thing if you're dealing with microservices. And it can do a lot of things. It can run your linters, your formatters. It can run your test. It can package code. It can resolve your third-party dependencies. It can do some resolution there. And the Git integration is really good. You can see in this command here, if I want to run my entire test suite, I can just run what's changed on my branch. So I don't have to run, hours of tests. What are linters? linters are, let's see, you have linters and formatters. Linters just kind of enforce some different code. Someone else can probably help explain this. Your code quality, I guess, might be a good way to say linting of linting and formatting. Yeah, code style. There we go. Thank you. Um, yeah, so they'll help you style your code with different rules that you can customize. And there's certain ones that work with pants, but yeah, as you know, because you can pass in this flag, you can run it across your entire repository or just what's changed. Um, and this packaging that Pants does is very nice. So they look through your Python files and they can infer all of your dependencies. You have to instrument your repo, but they can see which third-party dependencies you need, what dependencies across your code base you need. So if I just want to package get item.py, but they see I import retrieve item.py and item.py, it's going to package those all together for me. And if item.py requires a third-party library, it's going to package that as well. So Pants is very nice for packaging the your code for however you're doing it. You can do this with you can package Docker containers. You can create they use something called PEX, which is a Python executable. So you can package code that way. They have a lot of different options. And so Pants has a example repo for serverless, and I'm going to do a little a demo to show you a serverless function. We'll actually go ahead and deploy it and see what that looks like. Um, so there, let's see, it's just Pants build example serverless is the repo. In my example, I added some infrastructure as code, so because we are going to deploy it, so that's not in their repo. I don't know if they would even necessarily want that, but there's an example. They have some tooling specifically for packaging Google Cloud Functions and Lambda functions. And so I reached out to them and I said, hey, can we get an example repo for this? Because they have an example for like a Django application already. They have a few other examples too. So what's in here is really just a very simple REST API, and I broke it out just like I kind of explained. This is just a here's your that Lambda handler function, so it accepts an event and context, and this is Power Tools right here. I'm using their event resolver. And so if they see an event on this resolver come in on this slash item slash ID endpoint, the uh, the resolver finds this route. If it's a route that doesn't exist, it'll give me a 404. So it does a lot of stuff for you. And it is returning an item, which yeah, an item in this example, this would probably normally be a database lookup or something. And uh yeah, this if we look at this, it's a pydantic base model. So this is some of this type hinting, you get the validation, which and this code base really is it's a very simplified example. The example is to show what Pants does, not necessarily to have a complex I see, yeah, the code is pretty tiny. Oh, to see, sorry. Yeah, let me I see what you're saying now. I, is that a little bit better?
Yeah, that was good.
Okay. Yeah, all right. Sorry about that. Yeah, this is really to show kind of what Pants can do with this. So uh Pants uses these build files, and that's how it knows where Python files exist. And then you can use these other targets. So I have two targets here, one for a Python AWS Lambda function for the get item one, and one for manage items. So I kind of broke this into two Lambda functions. Uh, and all I have to do to package these is say and package, and they have some of their own little syntax. You can do like directories, and I don't know exactly where that syntax comes from, but what this will do is package up that code that I just showed. It's going to create it's going to find all the dependencies that it needs to package these and create some zip files. Let's see here, those I believe. Actually, let me do. We can look at these zip files. So it created two zips. One's for the get item lambda, one for the manage items. And if we expand it, we see that it has all of my third-party dependencies that it needed. So Pydantic, the Power Tools library, and it also has the code that uh, was from the example. And I added a little bit of infrastructure as code. This is CDK. There's a lot of ways to deploy code. Um, I would recommend doing some sort of infrastructure as code, just because if you start clicking around in the AWS console, it's fine if you're, learning and trying to, learn about AWS, but you can start to create resources that do cost money, and it can be a little bit challenging to even like find what you've deployed and what you've just kind of clicked through. So um, this really is just creating two Lambda functions, and then Lambda functions have something. This isn't a normal use case, but for this example, I chose to do these function URLs, which just give you an endpoint that to invoke uh, these Lambda functions. So I'm just going to go ahead and deploy this code. I've packaged it, and let's see, this probably take a couple seconds to deploy, and it will give me the two URLs for each of these Lambda functions. So I'll say yes, we can deploy that. And how CDK works is it creates CloudFormation templates, which is an AWS kind of specific way to deploy resources. It's very nice because they use constructs and you can reuse those. So if you want to customize something, it's a really nice way to do that. And then you can actually see it being spun up as it's deploying. I'm not sure if I will catch it in time, but yeah, here's my stack that it's creating. So it kind of goes through what's going on here, shows you what resources. Oh, look, it looks like that already. Oh yeah, it already completed. So I have two endpoints here. And so if we just take this get item one and but I need item. I can't remember if it was items or item, but let's see, item one. Oh, not found. So it must have been items. Okay, so yeah, there's my, usually that'd be a database call that I'd have to look up. But yeah, I mean, that's as simple as it was to have an endpoint to do something very small. So you can obviously imagine a lot of different use cases for this. And in that little bit of time, we are able to have a serverless function up and running. Let's see. So one thing to talk about with serverless is performance. So I've mentioned it a couple times, but you can't, just because it's serverless and you don't have to think about the server, doesn't mean you can just ignore other good Python practices. I'm sure you don't want to just have these massive code bases and dependencies in any Python code base. So the same applies for serverless programming. I mentioned again that same quote, know and reduce the code you load. And then I said you don't have to manage the servers, but there is a little bit you can do. So if we look at this Lambda function, there are some configurations you can do. So let's see. It shows me, how big of the zip file is. If we look here, you can set a timeout on it. the 3 seconds is the default. Apparently, I didn't set that in the infrastructure as code, and the default memory is 128 megabytes. That's not very much memory in terms of Lambda functions. Uh, and how it works with AWS is you're charged for the memory that you configure and for how long it runs. So you don't want to just throw the maximum 10 gigabyte memory at it. Uh, but the lowest memory also isn't always the cheapest because with Lambda, your memory is what determines the CPU, the vCPUs that you get. So there's an example. I took this right out of the AWS documentation. Uh, I forget what the Lambda function was doing. I think it was like calculating prime numbers maybe, and they took their average duration over 1,000 invocations and at these different uh, memory configurations. And if you look at each time with more memory, the time went down quite a bit. And if you look at the cost difference between 128 megabytes and a gig and a half, it's a thousandth of a cent difference. So if you can manage to fork over that extra thousandth of a cent, then you get 10 times the speed increase. And a lot of times it's actually cheaper to run on a higher memory configuration than the default. And another very cool tool, you don't have to figure this out yourself. There is a library called Power Tuning for AWS. Oh, I have a bad link, but I did have it open still. There's uh, this tool, which what it does is it deploys, there's another serverless tool out there in AWS called step functions, and it's going to run your Lambda function at several different memory configurations and give you your different time and performance outcomes. So these example Lambdas, I tried running it, and since it's just returning a string of text, I could, no amount of vCPUs or memory was going to speed up the 2 millisecond invocation time average on this. So I added like some kind of mathematical function and tried to just get a difference here. And there's also examples in the repo of this. So you can kind of see in this example, you see the cost, you know, it actually drops down and you have a major increase in your execution time. I mean, a decrease in execution time is much faster. Then at some point you lose that, your cost goes up to where it's probably not worth going up to 3 gigs to gain can actually, if you look at an example, this is 663 milliseconds and this is 620. So you're kind of picking apart milliseconds to I mean, not that this is a high cost either, but uh you don't need to crank it up to the highest. So you kind of find the sweet spot with this tool. So it's really nice for figuring out exactly what you need for uh, Lambda functions. So um, I learned a lot of this over the past year or two from hearing some great talks. So like I said, I got to figure out how to share these links, but are these slides. There was a great reInvent talk from the Power Tools team on serverless programming. There's one at PyCon last year from some people from Capital One that did really good, and then this is the one that AJ Steivenberg that talks about some more performance things. So, if anything, AWS has a pretty generous free tier. I think you get about 1 million invocations per month on AWS Lambda. Uh, Definitely play around with it, see what you can do with it. There's a lot of things out there, and in the serverless world there's a ton of stuff out there. So that is really all I had to share tonight. So happy to discuss, try to answer questions, or yeah.
Thanks so much, Tony. Any
Yeah.
questions?
I guess, I mean, this is kind of a pretty general question. Is this most helpful when you have like a million requests that you need to run through one function?
So it the obvious answer, it depends. I'd say there you probably have points to where Lambda's no longer the answer. If you need to, if your traffic's very spiky, that's a pretty useful time because or a pretty useful case because you can, like I said, you can scale right to zero with Lambda functions. So but you
What
can
does
you
that mean?
what scale to zero?
Yeah.
It means you aren't being charged, like a server running on,
Okay.
yeah, you don't pay for any compute unless your function's getting invoked.
Okay.
So, yeah, like things like, personal projects, you're going to stay within free tier for sure, and if you start getting Lambda functions that, I mean, you have to be having millions of invocations before you're getting charged even. So, yeah,
Yeah.
there's a lot of use cases.
I've also seen it used a lot on the infrastructure side for like one-off things or things that are happening once in a while, once a day, once a week,
Mhm.
stuff you need to schedule or whatever. It's really useful for that because then you're not running an extra scheduled service server. You just can have a bunch of Lambda functions that just run whenever you need them to.
Yep. Yeah, we use EventBridge is they have a essentially a cron scheduler, and you can just say,
Mhm.
you know, at these points in time throughout a day, week, month, whatever, run these functions. So certainly we'll ingest data from other sources that way, like where we need to um maybe like populate a cache, we'll do it, every hour and just have uh this Lambda function do a database query, populate a cache, and then the cache is, it's fresh every hour, but it's something where we don't need to hit a database every time, and we can have the data a little bit more quickly available. So,
And it's nice too because for someone from infrastructure that doesn't do as much coding, I can whip together a script that'll do something little really easily. Um, and then it's just that little bite that I need to figure out how to get to work right instead of having to have this big system that I'm managing.
yeah, you can have a very small, application, yeah,
Hmm.
small tasks. Yeah, it's very, very nice.
I also saw Paul in the chat was asking, is the example we saw like an API server that temporarily hosted at the given endpoint or URLs? Is that a good application?
Yeah, so there's a lot of ways to put, HTTP in front of a Lambda function on AWS. So there's load balancers. There's another service called API Gateway. Uh, that example was using something called function URLs, which is just a configuration on the Lambda. You just say, give me a URL to invoke this Lambda. And that's what that example was using. Um, the That one would be a little bit more complicated for a larger application because you're, there's no DNS behind it. So you would have to have some way to manage all of those individual URLs for Lambda functions. So that's probably not a common use case. I would say API gateway in front of Lambda is probably a much more common pattern.
Thank you. Any other questions, anyone?
Is it asynchronous?
Um, so I believe you can use async Python and Lambda functions, but the functions themselves they'll run concurrently. So you can there's a limit on that. I can't remember what it is because it changed recently, but these will kind of spin up, thousands of executions at a time that are all, running simultaneously.
Yeah,
So
that's what I'm really asking. Like if
yeah, yeah,
Amazon gets hit with a whole bunch, it tries to run it all at once with
right. It'll, yep. Uh, I think it's, I think it'll go right. If you open up a new AWS account like right now, they limit you to like 10 until you say, oh, this is a, I have a legit purpose for this. Then they bump you up to like 1,000 concurrent executions, and you can keep asking for increases. You can say, I need, especially if if you have a whole team of developers using this, you might need, 5, 6, 7, 8, 9, 10,000 concurrent executions, because that quota, it's account wide, so you could actually hit that pretty easily, depending on your use case. So
Cool.
another good use case is IoT. That was what I before I came to BusPatrol, I was working for Bissell in Grand Rapids area, and they were doing some robotic vacuums, and so we used MQTT, and uh, AWS has a managed MQTT broker, and you can just point those various topics right at a Lambda function, and so that's another nice use case too. Another instance of very like bursty traffic. You don't need servers running on all the time. So
Any other questions, anyone?